Welcome, everyone, to Firebolt Forward. Whether you're joining us live or on demand, we're thrilled to have you here. It is changing everything about how we are interacting with data, and yet most data platforms weren't built for AI first workloads. Firebolt is here to change that. Today's discussion will explore how modern cloud data warehousing should work with AI driven world, balancing speed, efficiency, and cost to power the next generation of applications. Before we begin, a few quick notes. This session is being recorded and you have an on-demand access after the event. We encourage live interaction. Drop your questions in the chat and we'll bring them into the conversation during our Q&A portion. If you're sharing insights on LinkedIn and X, use hashtag #FireboltForward so we can continue the discussion beyond today. Let me start with a question. What is your biggest challenge with AI-driven analytics? Slow queries, high cost, scaling beyond batch processing? Drop it in the chat and we'd love to hear from you. AI applications demand a new kind of data infrastructure, one that isn't just fast, but is also cost-effective, scalable, and AI-ready. Traditional data warehouses weren't designed for this shift. That's why we built Firebolt, the next generation cloud data warehouse for AI applications. And today, we'll show you how. Firebolt Forward is about looking ahead. We can power the next wave of AI-driven applications with cloud data warehouse built for speed, scale, and intelligence. And today we're going to be covering how vector search unlocks new AI use cases in data warehousing, how to optimize analytics performance while keeping cloud costs low, and how leading companies are designing AI-first data architectures. If you're a data engineer, analyst, or product leader, today's discussion will provide insights into how to future-proof your data stack for AI-driven workloads. To kick things off, we'll start with a look at Firebolt's journey and evolution. Igor Stanko, Chief Product Officer at Firebolt, will take us through how Firebolt has grown from high-performance cloud data warehouse into an AI-first platform. Then, we'll bring Devin Manager, Executive Director at ISG, for a fireside chat on industry trends and the future of data platforms in the AI era. And finally, Cole Bowden will share hard data on how Firebolt delivers the most cost-efficient analytics at scale. With that, let's dive in. Igor, the stage is yours.
Good morning, good afternoon, good evening, everyone. Welcome to the session and thanks for joining us today. I want to start with a question. What is stopping AI from reaching its full potential? The answer lies in the data. AI is evolving rapidly, but AI success isn't just about having better models. It's about having better data and robust data infrastructure. We've all witnessed the exponential growth of data driven by new sources, devices, and interactions. But here is the shift. Companies are no longer using the data to optimize internal operations. They're now leveraging data to build differentiated AI-powered products and services for their customers. As the market for intelligence data applications and AI source passed 260 billion, organizations that can unlock the full potential of data will have a massive competitive advantage. And yet, most companies are struggling. They are struggling because traditional data infrastructure isn't built for the demands of AI. That's what we're going to cover today. While many organizations are trying to adopt AI, there are also lots of challenges that these organizations face today. There is lots of industry news coming out regularly, as well as many analysts are projecting some major challenges that organizations face in adopting AI. To start, there is lack of AI expertise and skills to implement and support these AI applications. We witness a breakthrough in AI with generative AI technology. While Gen AI and LLMs provide lots of value and can power some impressive new scenarios, LLMs also come with hallucinations that need to be handled by exposing correct, fresh, and diverse data to provide accurate answers. The success of Gen AI is limited due to inadequate data infrastructure that is currently present in pretty much all the organizations. From that perspective, Gen AI puts even more burden on the data infrastructure by demanding low latency query responses. Gen AI application exacerbates the number of query requests that are being sent to data infrastructure, demanding even higher concurrency support from the backend systems. To support these modern AI applications, organizations lean towards existing infrastructure and deploy data warehouses. However, using existing data warehouses to power AI applications comes with lots of challenges. For the first, DWs are not, they do not support low latency queries and millisecond responses, which slows down real-time decision making. Imagine the scenario where a customer wants to purchase a product from a company, but inventory management system is too slow to respond, impacting user experience. DW lack high concurrency support that is absolutely needed for AI workloads. Consider a bank that uses AI to detect fraudulent transactions, where problems handling high concurrency loads to decrease number of transactions that can be processed. And above all, DWs are not efficient and come with high price tag and costs. Due to these challenges, some organizations opt in to leverage query accelerators and solutions like ClickHouse, Druid, and some caching technologies. While query accelerators offer low latency responses and they do lack standard SQL support, they do not support complex SQL query patterns, they lack ACID compliance, and they do not offer compute elasticity. Having these both technology stacks in architecture comes with its own challenges. Each stack requires a different yet unique skill set, and the overall solution comes with increased complexity. Above all, maintaining two systems leads to a high total cost of ownership. Now, I would like to introduce David Menninger, who is an executive director at ISG. Hey, David, welcome and thanks for joining us.
Hi, Igor. Thanks for having me here today. I'm looking forward to our conversation.
Absolutely, likewise. Hey, David, I wanted to have a bit of a chat with you about some of the latest trends and research that you and your team at ISG have done. To start with, can you give us some background on the sources of your research and what are you seeing regarding AI projects?
Sure. So we look at the market from three different perspectives. We look at enterprises and we conduct primary market research of what those enterprises are doing. So you can see here on the slide, we've done 44 different market studies across 14 different geographies. We look at software vendors and we evaluate their product capabilities. So we do over 100 buyer's guides each year. And we also look at what service providers are doing. And that's really the core of what ISG's business is about. We look at and advise on $20 billion worth of sourcing deals every year. And so what are enterprises doing in terms of acquiring services? Where are they acquiring services and what types of services are they acquiring? And so we have this pretty complete picture of the market, looking at it from all three sides. And so that's part of what informs what we're doing here. So why don't we look at what some of these different research endpoints show us on the next slide. We are looking at where does the money go in some of our work. So we looked at, this happened to be one of the surveys from one of the enterprise research studies that we do. And so we asked organizations, where are they spending their money? And this is specifically in the context of AI projects. So in an AI project, organizations are typically spending most, not the majority, but the largest portion of their money on application software. So that's why this conversation with you and I is so important today. They also spend about a quarter of their money on people to do the projects. And then about a fifth of their money on infrastructure, the hardware or cloud services to support that application. And then in many cases, they're using outsourced services to supplement their own personnel. So that's where the money is going. And, what we're trying to do is we're trying to help the listeners to this particular discussion understand how should they be applying their money toward the application software that they're using in their AI projects. So if we look at the next slide, we've got some information about what's important to organizations. So this is from a study on budgeting. Where are the IT budgets being allocated? So we asked organizations, how are you allocating your budgets? And in this particular slide, we're looking at, okay, as an example, let's look at your largest contracts. What were your largest contracts about? And they could select more than one thing here. Right? They could say, oh, yeah, we did several different things in the contract. At the top of the list, you see cloud services. So, the Firebolt offering right in the sweet spot of what organizations are doing. They are the largest contracts, had the most amount of cloud services activity involved in them. followed by application development, IT security, digital transformation. Those things are not surprising. Then data and analytics services, application maintenance, and then artificial intelligence. So of the top 6 or 7 here, you've got 3 of the things that Firebolt is involved in are top priorities for organizations as they're allocating their IT spend. And allocating their IT spend is just one measure, but I think it's an important measure, and it's one to understand. If we're going to be spending this money, we want to be spending it wisely. So that's a little bit of a view into the research of what organizations are doing.
Awesome. Just to summarize, AI and cloud services are among the top of things that enterprise customers and enterprise companies are doing in the cloud.
Yep.
Can you comment on what are their most important priorities and where are they spending their IT budgets and why?
Sure. So for this, on the next slide, we looked at where organizations are, how much they've adopted now, and what do they plan to adopt in the future, right? I mean, part of the reason to have this conversation is so that organizations can know what to do next. Right? It doesn't matter so much what they've already done, but looking at what they've done and where they plan to go presents an interesting perspective. So if we look at what they've done already in the cloud, the dimensions here, the further to the right, the more they've adopted already, and the further up in this chart, the more they plan to do in the future. So if you look at these 2 dimensions, the 3 things that we were just talking about within the cloud context, cloud, data, and AI, those 3 things are the things that are at the topmost and rightmost of this chart. So there's a lot of adoption of data and platforms in the cloud. There's a lot of adoption of BI and analytics in the cloud. There's less adoption of AI and data products so far in the cloud. But if you look at where they're going to be doing more, they're going to be doing more around AI and BI in the cloud. That is clearly a big part of what organizations are doing. And let's just say you took those 2 at the top out, right? They're somewhat outliers, right? There's so much interest in doing things there. Let's say you took those out. Data platforms and databases would be near the top of the rest of the list. So, we really are talking about stuff that is at the top of, the interest level in terms of what enterprises are doing, both now and into the future. So that's one thing that we look at. If we go to the next slide, we've got some information here on, it sort of backs up the previous slide that we were looking at, but we've got some information here on current spending and planned spending. So if we look at current spending, AI initiatives are the second biggest area of planned spending. And then what we did was we asked organizations, well, what are you planning to do in the future with your budgets? How much will they increase or how much will they decrease? A couple of things to note. The average increase was approximately 2%. I think it was a hair under 2%. AI initiatives are planned to grow at 5.7%, almost 3 times what the average growth is in any particular area of the IT budget. So you can anticipate that it's very likely that the IT initiatives would catch up or surpass customer experience initiatives, or be roughly the same. So it's going to continue to be one of the biggest areas of spending in the coming year. Well, at the time the study was done, if 25 was the coming year. It was just at the beginning of the year. So during the course of this year, we're going to continue to see large amounts of spending around AI. So that's part of what we wanted to share here from our data, is that these are very important areas for organizations to focus on and to get right. And if we go to the next slide, I tried to point out some of the reasons why data and AI are so closely linked, right? Sure, I mean, ostensibly AI is the topic, but data is so integral to AI that you can't really do a one without the other. Part of the reason for that is that just having data is not sufficient. The data's got to be of high quality. If you don't have good quality data, you're not going to have good quality outcomes from the AI work that you're doing. In the case of predictive analytics, you're going to get errors in your predictions, or your predictions will be less accurate. In the case of generative AI, you're going to get hallucinations, right? So a lot of work goes into preparing that data before the AI project is actually live and in production. So that's one element of why data is so important. You need a large amount of data to train these models, right? And so that data's got to be collected and stored someplace. Other issue is that the data is not static. We're becoming more and more real-time oriented, right? So if we ask a question, we want responses that are up to date now. If we've got some sort of customer situation, we want to know all the latest information about that customer to incorporate into the responses that we're preparing. So the notion it has to be continuously updated and continuously consumed, that's an important data operation. And then, if you look at another way to look at this is that when we look at those services that our enterprises are purchasing, the large AI deals, half of them had data services as part of the work that they were doing. So the two are really inseparable. You can't do AI without data, and nearly everybody that's doing data is using it to fuel some sort of AI-based analyses or projects.
Amazing. So maybe that's the question. When you talk about AI, are you referring to generative AI or all of AI? And what do we need to know about data requirements for different types of AI?
Sure. So we actually see that although generative AI gets all the attention, right? It's sucking all the air out of the room. That's not really the reality. It's the latest thing. It's the new thing. It's getting a lot of attention. But it turns out that only about half of the AI spend in organizations is on generative AI, and half is still on predictive AI. And we can't lose sight of that. That's important, that you want to be able to do both. Generative AI is great. It's a whole new class of use cases that we can support now. It provides, broader access to technology and to even predictive AI capabilities. But you do need to be able to do both. You need to be able to do predictive AI and generative AI. There are differences in, the type of information that you might use in each of these. Generative AI tends to be more about semi-structured or unstructured data, but it also utilizes structured data. If we think about, and one of the things we do in generative AI is we take semi-structured data and we make it more structured, right? We create vector representations of the data to make it a more structured representation. So both of these types of AI require structured data. Now, there's less unstructured data used in predictive AI. Predictive AI is much more about structured data. But remember, that's about half of your spend. So it's important that you get that part of it right. Both of them require fresh data. We're now expecting that if we're, a generative AI response maybe doesn't have to be sub-second, but, we don't want to wait a long time for those responses. And where we're headed is agentic AI. In agentic AI, what we're trying to do is automate more of the processes. So we have multiple different tasks. Each one of those might be something you could do perhaps today with a generative AI chatbot, but we're stringing them together and we're coordinating those actions. And so, we're doing some reasoning as to what is the right action to take and then, executing that action. So again, we're using structured information. The way you learn and the way you improve those actions is by capturing information about whether or not those actions succeeded. So, there are some differences in the type of data used in each, but structured data is an important element of both of those. And if we take a look at the next slide, so we see here that what we make these assertions about what we see going on in the market. And what we see is that notion of taking the unstructured data and making it more structured is an important element. We're going to continue to do that. And, the purpose of doing that is to improve the responses of the generative AI requests that people make. It's a way to ground the responses, to tie them to information perhaps that's specific to your organization. So you have, specific information about your products and services, and retrieval augmented generation and vectorization of the information is one way to do that. It allows you to search for things that are similar in your knowledge base to the question that's being asked. Let's go on to the next one as well. Another element of this, if you talk about the types of data that are required, cloud data warehouses in general have rapidly moved toward object storage, and that object storage was driven initially really by one objective: lowering the cost of storing all this data. So, we have large amounts of data. We're thirsty for data. We always want more data. And so object storage was a way to lower that cost, but it wasn't very performant at the beginning, right? We just had these large files and okay, so we could store the information. We couldn't access it all that effectively. We've gotten better and better as an industry. And one of the things that happened is that we've created these open table formats that can be shared across different implementations. And those open table formats are based on Parquet, and we see that they're very widely used. If you look at the chart on the right here, more than half of the organizations are in production with object stores. And most of those object stores are in fact based on the open table formats. There are multiple open table formats, but realistically, Iceberg has become the de facto industry standard. Multiple vendors have adopted it. Even the vendors behind some of these other standards have adopted Iceberg as well and created at a minimum some interoperability. But what we see in our research is that Iceberg is the most common of the open table formats. So that's gotten us to the point where we can handle very large amounts of information. And that's important. If we go on to the next slide, why are all these things happening? Why are these different pieces of the puzzle coming together? Because performance, scale, and cost are all important considerations. Right? We talked about needing to inference in real time. Well, it's not just inferencing. You want to get that data prepared quickly. You want to be able to collect lots of information and keep it up to date. The models that you train need to be retrained, right? You want to be able to do all that quickly. If you have a model that's out of date, you want to get it updated and replaced as soon as possible. We've mentioned inferencing multiple times. In terms of numbers of users, one of the things that generative AI has done is brought many more users to the table, so to speak. Nearly everybody, I suspect, has tried some sort of generative AI activity. So we've got many more users. So you not only have to scale in terms of data volume, you have to scale in terms of users. And that balancing act is difficult. And often it comes at the expense of cost. So sure, we can handle more users, just throw more resources at it. Well, okay, that might get you the performance that you need. That's not going to make your CFO happy. So you got to take all these things into consideration. And then one of the most difficult things is what we learned over the past 5-10 years is that being able to predict costs is one of the big factors. So not knowing what your costs are going to be is a big challenge. That's a challenge for organizations. So the costs have to be reasonable, but they also have to be predictable. So, those are some of the things about what's happening with data and why these things are happening and how they all sort of come together into this trade-off between performance, scale, and cost, and trying to get all three as best you can.
This is great. Can you comment also on what our audience should do next with this information?
Yeah, so we try to share this information so that you can figure out what to do. And I've got to put a few next steps together on the next slide here. I suspect, based upon our research, that most of you are already exploring cloud data platforms. If you're not, you should be, right? Part of the reason for that is that these implementations require a lot of servers. Setting up those servers and managing those servers can be difficult. And so the more you can offload that work to the cloud provider, the better. So cloud data platforms, if you're not already exploring them, you should be. You need to understand your workloads. Your workloads for AI are going to involve data. You need to understand what those requirements are, and you need to make sure that you select a solution that will support both those data and AI requirements. Absolutely have to consider the cost and performance characteristics. If you go into this thinking that you'll just throw more resources at the problem. You may be able to accomplish service levels. You're not going to meet your budgets. So you do have to evaluate both of those things very closely. And then generative AI, it's taking all of the getting all the attention right now. You've got to be able to support that as well. And so here, part of what we're talking about here is the ability for your cloud database to be able to provide those vector storage and search capabilities that are so important to generative AI. You want to try and have all these things put together into one place. Just makes it easier for you to do these implementations and manage them. And then a lot of what's happening around AI is incremental steps, right? So don't just think about what you're trying to do today. Think also about what your future requirements are, and make sure that you select a platform that's going to accommodate both of those current and future requirements that you anticipate. That's what I would do in terms of trying to get started.
Got it. Awesome. This was very insightful, David. Thank you so much for joining us today, and really appreciate everything you mentioned. Thank you.
Glad to be here.
I would like to take a moment and use the next few slides to introduce Firebolt and talk about why Firebolt is essential for data-intensive AI applications and analytical workloads. Behind every successful AI application lies a massive data ecosystem. AI feeds on enormous volumes of data to generate insights. But success of these systems hinges on the underlying data platform's ability to process, retrieve, and serve data efficiently. Organizations today are building and implementing various applications, ranging from generative AI and agentic AI applications that David mentioned in his talk, to data-intensive apps and business intelligence scenarios. Many organizations today are adopting lakehouses and open file formats with the promise of having a unified data layer that supports various purpose-built query engines that sit on top. Main value proposition being to avoid complex and costly data movement operations across various data stores. We at Firebolt are seeing lots of organizations adopting Iceberg as a core technology and open file format to support those lakehouse deployments. At Firebolt, we see Iceberg as a core data layer to support these AI-driven applications. Firebolt as a data infrastructure powers AI applications with low latency and milliseconds query responses, ultra-high concurrency and high throughput, unmatched cost efficiency, and flexible infrastructure. AI workloads are inherently more demanding compared to traditional analytics. Answering a single prompt question often involves generating numerous queries across multiple datasets, significantly increasing the load on the backend systems. Firebolt's low latency capabilities deliver results in milliseconds, even for the most complex queries, while its high concurrency engine delivers thousands QPS throughput. Firebolt also comes with lots of flexibility built in. Functionality like multidimensional elasticity that allows users to both scale up as well as scale out to achieve scalable and cost-effective query processing, to granular scaling through which our users can fine-tune their price performance characteristics for various workloads that they run. This is unlike other systems in the market today that provide single-dimensional scaling while doubling compute capacity with each incremental step. With Firebolt powering AI applications and workloads, architecture is drastically simplified as Firebolt merges these low latency and high concurrency capabilities together with mature data warehousing capabilities. Beyond the value proposition of low latency and high concurrency to serve these AI applications, Firebolt value proposition for AI workloads extends to supporting high-speed data ingestion, which ensures rapid ingestion and availability of both structured as well as semi-structured data sets to feed those AI systems, efficient data processing to support the preparation of clean data sets, regardless of the data size or complexity, lakehouse integration with Apache Iceberg support, and finally, fresh data availability to provide AI models with timely access to data sets, reducing inaccuracies and minimizing hallucinations. The core value proposition that Firebolt comes with are cost efficiency and flexibility. To help our users realize even bigger efficiency gains, we are introducing a new Compute Optimized family as an additional option to be used. Compute Optimized family comes with 2x less expensive price point compared to our existing Storage Optimized family, and brings that starting point to $1.4 per hour. There are multiple use cases and scenarios where this new compute family could be attractive. As an example, consider development environment that do not come really with strict performance SLAs. Being 2x cheaper, compute optimized family represents an attractive value proposition to save cost for the development environment. In addition, not every database and data warehouse comes with hundreds of terabytes of data. For those smaller databases and data warehouses with few terabytes of the data, the compute optimized family is really attractive option and provides excellent price performance characteristics. To make things even more compelling for our users and to enable even less expensive starting point to experience Firebolt, we are happy to announce general availability of new Firebolt Standard Edition. This Standard Edition comes with core value propositions such as low latency and high concurrency, global consistency, and async compliance all built in. Two compute families, storage and compute mentioned earlier, are also available, giving our users even more flexibility to improve price performance characteristics. With less than $1 per hour starting price, this is a very attractive offering for those organizations that do not require compliance certification or advanced features such as AWS private link and multi-cluster support. There are lots of AI-oriented investments and projects that are happening today. While adoption is clearly widely spread, currently there is not a single and predefined data stack and architecture that exists. Lots of organizations are running experiments to determine the best technology stack to support a given AI use case. In addition, there are just lots of startups out there that are being born to support AI modernization efforts. To support all these efforts, we are excited to announce a private preview of Firebolt Core Edition. Firebolt Core is completely free offering tailored towards organizations exploring self-hosting models. Firebolt Core is a downloadable software that can be deployed locally or on AWS or GCP cloud platforms using a Docker image. Firebolt Core supports both single node as well as a multi-node deployments to meet diverse query processing needs. And last but not least, we are happy to announce private preview of Apache Iceberg support. As mentioned earlier, we see lots of organizations exploring and de facto taking dependency on Iceberg as a primary data storage format for analytics-heavy workloads. The value proposition of having a single data copy with multiple purpose-built engines while avoiding expensive and costly data movement is just too compelling for organizations. With that in mind, Firebolt now can be run on top of Iceberg directly without requiring any additional data copies. To preview native Iceberg functionality, contact us and we will be happy to engage and get this preview enabled for you guys. During this presentation, I talked a lot about low latency and performance under concurrency. As we built our product, we were looking at ways to validate some of these points and claims mentioned today. As part of that exploration, we investigated existing industry benchmarks that have traditionally been used to assess data warehouse performance characteristics. Things such as TPCDS and TPC-H benchmarks come to mind. Those benchmarks have existed for a while and were designed with additional reporting scenarios in mind. And they represented really the state of the market 20 plus years ago. These benchmarks are not designed with low latency and high concurrency in mind that new AI applications exercise. What we've done instead is we investigated various queries and query patterns that our existing customers and prospects exercise using Firebolt. We patternized these queries and created a set of 25 query patterns that come with various levels of query complexities. As such, queries exercise complex group bys, where conditions, join conditions, where in some cases we modeled the query pattern with 50 plus way joins. We named this benchmark FireScale. We then had two runs of using this benchmark. One run was focused on running queries in a power run mode, meaning queries were running sequentially one after the other one, and in concurrency mode, simulating multi-user scenarios. In the next section, my colleague Cole will walk you through the results of these experiments. Cole, please take it away.
Hi, everyone. Thank you to Igor for the intro. And to introduce myself further, my name is Cole Bowden, and I'm a developer advocate here at Firebolt. I've been pretty hard at work running benchmarks for the last couple months to get some results to compare Firebolt to other cloud data warehouse vendors. Now, benchmarks can be contentious at times, and they do have flaws, but they're also really the only way to fairly compare different systems in a controlled environment. So we've done our best to be as scientific and fair as possible and to get results that we can stand behind and be proud of. As part of this initiative, we're actually publishing all of the data, queries, and clients used to run these benchmarks, and you'll be able to find that on the Firebolt website and GitHub if you go looking after Firebolt forward. So you should be able to reproduce this, but that's enough on that, and let's start talking about it. Real quick, before we get to the numbers, I'd like to discuss how we did it. So building the FireScale benchmark, the queries that we selected were selected from customers and users who were running queries in Firebolt itself. We selected 25 queries that ranged from very simple to very complex. Simple queries might be a simple select statement with a filter or two, whereas the complex queries may have many way joins and some CTEs, and there's one query in particular that's north of 300 lines of SQL. So they run the whole universe of possible queries, and we think that they represent what you might want to do with a data warehouse very well. The data set we used was taken from the UC Berkeley AmpLab benchmark data set. We did it at a terabyte scale, which means that the largest table in our data set was 1 terabyte. And we actually added a couple more tables to this data set to better simulate the way the real world works, because in the real world, you're not just querying data from 1 or 2 tables. In running this benchmark on different data warehouse vendors, we tried to be as consistent as possible. That means that we use the exact same queries, the exact same data, ingested from the same source in the exact same region of US East, and using the same clients to run the benchmark. For our power run, we used a Python client, and for our concurrency benchmarking, we used a tool called Grafana K6 to better test and saturate the different engines or warehouses or clusters across these different vendors. So that's kind of how we set it up, and I'll get a little more into the methodology after we present the numbers, but let's get into them, and I can present first the performance numbers of the power run. So this is when we're running the 25 queries in the FireScale benchmark sequentially. Query 1, then 2, then 3, all the way through to 25. And as you can see from this chart, Firebolt is very fast. In fact, it's so fast that our smallest engine on this chart, a single node small engine, is faster than any configuration we tested on any of our competitors. So even a Snowflake XL warehouse could not achieve the performance of a Firebolt small, and that's despite being nearly 40 times the cost. Redshift and BigQuery similarly were significantly slower than Firebolt in this testing, and Firebolt maintained a performance advantage from around 4 or 5 times Snowflake to up to 15 or 20 times Redshift in certain configurations, and as well as about 4 or 5 times faster than BigQuery, depending on exactly what Firebolt engine you're running and comparing to. So we're very proud of Firebolt's performance here, and I think this benchmark demonstrates just how low latency those queries in Firebolt can get. Next, I'd like to talk about price performance, because Firebolt's engines in these benchmarks were actually less expensive than our competitors. We were running on our compute-optimized compute family, which means that a Firebolt small engine actually cost half the price of a Snowflake extra small engine, and that means that that performance advantage from the previous slide turns into an even larger price performance advantage on this slide. Firebolt was able to run this workload both faster and at a lower hourly rate than our competitors, and that leads to a price performance advantage over Snowflake of somewhere around 8 times better, against Redshift of somewhere around 10 times better, and against BigQuery, because they're serverless, this isn't the best comparison for them. Serverless setup is going to perform better when the queries are spread out as opposed to run sequentially like this, but I believe the number is somewhere in the vicinity of 70 times better, which is really impressive for Firebolt. And again, that price performance ratio means that not only do you get better performance for those low latency and interactive workloads, but also you can get that at a lower price. Now, I'd also like to show this graph that does performance versus cost. So this is all of those slides, those past 2 slides, and all of those engine configurations presented in this scatter plot, where you can see Firebolt engines are consistently both faster and less expensive than those engines on Snowflake at Redshift. BigQuery we left off of this graph because the dot for BigQuery is like way below the bottom of the chart and doesn't fit on here and would have made the graph very squished if we had included it. So the next thing to talk about in terms of benchmark results is our concurrency results. So on this slide, we've actually controlled for engine cost, So the Firebolt, Snowflake, and Redshift configurations you see here from left to right all cost comparably the same amount. And on concurrency, you can see that Firebolt is simply achieving QPS numbers that our competitors cannot. So when you have high concurrency, many users submitting queries, and you need that high query throughput, Firebolt is able to achieve that far greater than its competitors. And as you can see, we're getting 2,500 QPS on a relatively large engine with 8 clusters. Another important thing to call out regarding this is that 2,500 QPS was achieved with a median query latency of 120 milliseconds. So it's not just that it's 2,500 queries being throughput per second, but also that they're happening in the blink of an eye, which is truly significant when you're using a user-facing data app or an AI application where you want to have many users accessing the data. Being able to handle that workload and get them the results back so quickly makes for a better user experience, and is part of why we think Firebolt is so good for this use case. So that's it for the numbers. I'd like to go back to that methodology slide just a little bit to talk about how this was set up and how you can run it yourself. So as said, we used a Python client to do the power run, which means that we were doing 25 queries in sequential order. We warmed up the engines with a couple queries to select the data and make sure that we weren't reading from cold storage. But we did that in the same way across every system. And then we measured the latency of queries client side. So that Python client was on an EC2 instance in the US East region, which is also where all of our cloud providers were set up. So we were minimizing latency and making sure that these results came as consistently as possible. For the concurrent benchmarking, we were using a tool called Grafana K6 in Node.js. And the way that worked is that you select a number of virtual users, and based on how many virtual users you have, they will all submit a query, and as soon as they have a result, they'll submit another query. We made sure to select a virtual users number that fully saturated the engines of each of the Firebolt and competitor systems. And we also tested to make sure that increasing VUs further wouldn't lead to either increases or decreases in queries per second, to make sure that we were fairly and fully testing each system and not leaving any excess hardware on the table. So we were able to do that, and that's why QPS numbers you see actually scale quite well for Firebolt and Snowflake. They're both relatively linear here. It's just because of that performance and price performance advantage of Firebolt that it's able to achieve numbers that are far greater in terms of absolute values. If you have any questions about benchmarks, feel free to reach out to me directly, type in chat, or comment on the repository for Firescale on GitHub. We'd really like to hear feedback about this. We want to make sure that we are considering everything we can. And if you want to see us test other vendors or other systems, we'd be happy to do that as well. So thank you very much. And I'd like to kick it back to the rest of the squad presenting Firebolt forward. Thanks for your time.
We started today by looking at the bigger picture, how AI is transforming data infrastructure and why modern analytics needs a new approach. Then David Menninger shared market trends and independent research, reinforcing the shift towards performance-driven cloud data warehousing. Finally, Igor walked us through the Firebolt's evolution, and Cole showed us the benchmark results that prove it's not only one of the fastest cloud data warehouses, but also the most cost-efficient, significantly outperforming Snowflake, Amazon Redshift, and Google BigQuery. But technology alone isn't the full story. Real-world results matter. Now, we're going to hear from Rio and Bigabit that has put Firebolt into action at scale. Now we're ready to start our customer spotlight session with Ryan McWilliams and with Yaron Cohen-Leo. We have these amazing customers that are coming to share their experiences with Firebolt, how they were dealing with the pain points, how they have changed with Firebolt, and also how are they looking for in the future, including thoughts about how AI is changing the marketplace and how we are evolving as companies trying to really future-proof our tech stack. So thank you so much for joining us today. Why don't you both introduce yourselves, introduce your company, and let the audience know what amazing things you're doing.
Sure, I'll start. So my name is Ryan McWilliams. I'm the CTO and co-founder of Rio, which is an online headless CRM platform. So how we've used Firebolt and how we came into Firebolt is we have very large clients doing e-commerce across our platform that are very data-driven. And our application is very complex and with lots of flexibility. So with that, reporting becomes a challenge. Analytics become a challenge with our clients because everybody looks at things a different way. Before we started with Firebolt, we were paying astronomical costs to AWS and just trying to solve our issues with MySQL and RDS and Aurora, and nothing would work. So once we got started with Firebolt, not only have we not been asked about slow queries or anything like that in the past 2 years, but we also save money per month on the amount of money we pay Firebolt as opposed to AWS. When it comes to the future for us, I think some AI tools that we're looking into is more predictive analytics for our clients, so they can start to really pan out and determine how they want to spend their money on advertising to provide better experiences and make more revenue for their customers. So that's kind of what we do and how we use Firebolt.
Cool. I'm Yaron. I'm leading the BI in Bigabid. Bigabid is an ad tech company trying to promote advertisers via the ad tech world. We use machine learning in order to target the correct clients to install our applications. Before starting with Firebolt, we had different scenarios. We worked with MySQL, RDS, Redshift, and we started understanding that we can't analyze everything. Our campaign managers always wanted more and more and more. And a lot of times things got stuck, or we had to do some trade-offs. So whether we would like to analyze a couple of months or a bit more, or we want to see the entire data funnel. And then we started on the lookout, and we reached Firebolt and started understanding exactly what we were trying to look for. And that was basically a good data warehouse where we can start pushing a lot of data and analyzing way more data than what we could before. And we separated both of our scenarios. One was our BI platform, which is under Tableau, and we started creating everything from scratch all over again. And the other part was bringing our platform, our campaign managers platform, to work in near real-time data. And we're talking about a lot of data. Ad tech world talks about tens of terabytes a day. And we started creating this platform, ingesting data near real time, and creating the platform itself to analyze and send queries that perform in milliseconds. And after, let's say, a few months of adoption from our campaign managers, there was a full adoption. And for now, we're working both on the BI platform and the campaign managers platform, and it serves almost everyone in the company. So that's basically what we achieved this far. And in regards to the future, so almost everyone in Bigabit wants to work with our platform, since it creates analytics in near real time and quick analytics. So the AI side is creating more predictions on our data, giving our data scientists work with this data, and also create more algorithms that runs on it. And I think that's basically it.
Fantastic. Thank you so much for sharing. So it seems actually that both of you have a very similar tech stack before adopting Firebolt. Let's actually go into the first question, which are like, what were the biggest pain points in that data stack? Because both of you have, very similar, right? You both have AWS, have MySQL, RDS. Tell me a little bit more about like what that latency looked like.
For us, it was the biggest pain point with speed. We have our analytics is basically real time pivot style, kind of working with the spreadsheets basically, so people can slice and dice them anyway. They're looking at years worth of data. We have companies doing, lots of revenue per month through our platform. So before Firebolt, it's probably every day I'd be pinged with somebody saying a report's taking too long or it's not completing at all. So that was by far the biggest pain point that we had.
So on our side, it's like Bigabit is a startup. So we try to analyze and understand almost all of our client needs. So in Tableau, we couldn't expose a lot of data, basically because we used Redshift and MySQL, and query performance there was really bad unless we used an extract, and using extract has its things in Tableau. So that was one point, but the other point was the platform of the campaign managers, as I explained before, which was having a lot of time on ingesting data, and recovery on wrong data took a lot of time, and we had a lot of downtime that we could have saved. And basically our queries that run on that platform took a lot of time, and the campaign manager could only look like on a short window. And now with Firebolt, they can do almost everything they wanted, and new features and new metrics are coming in near real time, and it's very easy to onboard it.
Thank you. So, Ryan, you said something that really caught my attention, which was like people were complaining. It was like too long, not completing. And I think that this happens quite a bit, right? It's a common pain point. But a lot of the times that I work with customers, they come up with the question of like, yeah, but like it's the way that we work. Doing something new is going to take too long, or we're going to have to migrate the data somewhere else, and that's going to be such a pain. Like, what is the difference between getting to the pain point where it's so much that you're ready to move on, which is like essentially what is the trigger to like search a better solution?
Well, for us, it was, we provide a lot of flexibility with our clients, and I think, everybody looks at their data differently. So, there's different ways people track their ad spend and their revenue and all their marketing online. So, some people might want to look at one field and that's where their key metric is, and some people might want to look at the other. So for us, it was a matter of chasing down every single scenario where, adding indexes and, everything that you need to do in MySQL to make things a little bit faster. So the triggering for us to move that over was the development time that we were spending trying to solve problems, for our clients and try and make reporting faster. So, it was worth the time integrating with Firebolt. And I think we're at the point now where, we are ingesting a lot faster. So there's no, if people want to see data in real time, then we can still provide them that with our application. But once they start using bigger date ranges, then we're just a little bit less real time, I guess is what I'd say. But yeah, that was the main trigger for us, was the development time we were spending chasing our tails because we'd solve one problem and maybe cause another one somewhere else.
So on our end, I think it was a mixture of things. It wasn't just one trigger. So first of all, we had a campaign manager's platform that took a lot of time. Recovery was really slow, and our campaign managers had a long time on understanding how the campaign are handling. So that was one point. The other one was cost effectiveness. So we paid a lot for AWS, Redshift, S3, and we wanted to find a solution that will fit our needs, and it wouldn't take a long time on onboard it. And Firebolt helped us on the initial onboarding. And I think that's like the two things that were the most important for us, being fast enough to load everything that we need.
With the onboarding, can you tell me a little bit more about that? Obviously, you're when you're looking at other solutions, you're looking, maybe through an RFI or like making comparisons with other tools. And you're telling me that the onboarding portion was one of the reasons why you decided to go with Firebolt. Can you, tell us a little bit more?
So we compared various solutions, and the support we got from Firebolt was first understanding how to optimize our queries, and knowing and understanding that it's a pretty quick intake, and it wouldn't take long for us to model the data, since we already had some models that ran in production. So we just did a few reframents on our modeling, and with the help of the technical account managers. And in addition to that, we got some onboarding phase where some solution manager used to do some calls with us and helping us optimize everything until we reached the part where most of our important queries ran faster than the competitors. So that's helped us understand what's needed.
Yeah, us too. I mean, the customer support we got from the Firebolt team was, second to none. And that's kind of the main reason I think the way we were ingesting the data and the challenges that we had, I think Firebolt was, to be honest, at the time, they didn't have the solutions necessarily. But they were eager to make it work for us. So they were continuously, developing and making things better, to the point where, our ingestion time went from, it used to take maybe, I don't know, 30 minutes to kind of ingest some data for ourselves, because we do it across a lot of different schemas and a lot of different clients, to now I think we're probably at about a minute, so just their ability to continue to develop and work with us, and what was why we chose them and why we've stayed with them.
That actually leads to my next question. And I want to know more about the future, right? So one of the themes that I'm hearing from both of you is that Firebolt is willing to grow with you. But what does that growth look like? What does that future look like? And, specifically, I'm seeing a lot of customers that they're adopting AI. They're trying to like reach, new audiences. They're trying to create new solutions. They're trying to implement AI to have better performance of internal teams. So this is kind of like a two-part question, right? So like first is, how do you see the future for your company and where you're trying to reach? And then second is, how do you see that AI portion playing a role in it?
So I think on our end is like onboarding more and more clients inside Bigabit. Our main clients are internal, and our data science teams can use Firebolt to leverage their machine learning algorithms, and it will help them develop even quicker than what they're doing now. In addition to that, our client base is always growing, so understanding what engines do we need, what will our data look like at the end of additional customers, that will help pretty much. Of course, helping campaign managers understanding how they can leverage data. Since we're a data company, our product is data, and helping our campaign managers understanding what they should do if they see like let's say a data breach or something that they should promote and they missed it, since our dashboards didn't aim for that specific point. That will be amazing.
Yeah, I think for us, we're looking at, we deal with a lot of e-commerce brands that do subscriptions, things like that. So for them to be able to predict, for us to be able to push forward and we do some machine learning, but not, as much as we probably could be doing in terms of AI. So I think for us, to be able to predict revenue, predict, inventory stock needs to be, all of those things is kind of where we're going to start pushing our business into more of a predictive model.
Well, thank you so much for sharing that. I have one last question for both of you, and is this one. What is one piece of advice you like to give data teams looking to adopt a new tech stack, kind of like Firebolt?
I think for us, I think kind of what I said previously, it is, the main reason. The biggest reason that you would move to Firebolt is just because you're solving problems that, right now we wasted so much time optimizing queries for clients, asking questions why things are running slow, them asking, and also being button hooked with the amount of, the amount of data we can show and the amount of the level of, the cool metrics that we can actually provide people. Now with Firebolt, we don't have those issues. So, I think the biggest piece of advice for me would be, it does take a little bit of time. Like if you take the time to integrate with Firebolt, you're going to save time on the back end. Not only that, we probably save 50% of the money that we are spending on AWS and RDS and other solutions for analytics when we moved to Firebolt, just because the way that it runs, the way that it's set up, it's fast, it's available, and we can always count on it.
So I would split my answer into several parts, since when we're talking about data solutions, you first need to understand which data tool will provide the best performance for you. So I think the first thing is understanding what's your data model and examine it across platforms. When we did it with Firebolt gave us the best solution, the best solution, let's say, in terms of queries quickness. And we, of course, needed to be a little bit patient, since we were boarded Firebolt a long time ago, and we had some pain points, let's say, but the customers support and the technical teams really helped us in onboarding things and creating new features. And right now we're at the spot where we can onboard new things, new solutions to our teams. Onboarding on new algorithms takes a really small time, and it goes to production way quicker than it used to be before. Our ingestion is real near time, and it really helps our campaign managers understanding if they have an issue with the campaign. And of course, they're working on it almost all day long to understand if they have an issue or if they can promote additional campaigns. So basically, I would suggest understanding what's your data model, what you're trying to achieve. Is it queries quickness? Is it analyzing a lot of data, and understanding which platforms are you going to use when you do that?
Thank you to our amazing customers for sharing your journey and how Firebolt has helped tackle performance and cost challenges while preparing for AI-driven applications. It's always powerful to hear firsthand how companies are optimizing their data infrastructure to keep up with growing demands. Now that we've seen Firebolt's impact in action, let's take a closer look at what's powering these results and what's coming next. In this next section, we'll explore Firebolt's latest innovations. We'll also walk through our product roadmap and show these capabilities live on product demos. To lead this discussion, please welcome Benjamin Wagner, VP of Engineering, Hiran Patel, Head of Product, and our superstar intern, David Stanko. Benjamin, the stage is yours.
Thank you, Monica. Today, I'm really excited to be talking about the product innovations the Firebolt team has been working on over the past months. This has been huge effort from both the product and engineering teams, so I want to very explicitly shout out all of the hard work that went on behind the scenes here. We've recently launched geospatial support in Firebolt. This means that within our new geography data type, you can store points, lines, polygons, and combinations of these. You can also get in data very easily. We support GeoJSON, well-known text, well-known binary, and the extended formats of both of these as well. In terms of SQL dialect, at Firebolt, we always try to align with Postgres. We're doing this because it makes it extremely easy to actually get started on Firebolt and be productive on top of our platform. For geospatial, this means that we aligned with the Postgres extension of Postgres. So functions you know from there will now also work in Firebolt. Under the hood, we're of course doing a lot of heavy lifting to make this as efficient as possible on massive amounts of data. So even though the dialect looks like Postgres, under the hood, this is our completely own implementation built for massive scale. For example, we're leveraging columnar storage. We're leveraging a lot of indexing within our storage format to be able to prune data efficiently. We leverage vectorized execution to do fast geospatial processing. And there's just a lot of performance tuning across the stack that's happening behind the scenes to make this work really, really well. We're also incredibly excited to announce that Apache Iceberg support is now in private preview within Firebolt. In terms of SQL dialect, we've made this very easy to use. You can simply use our read Iceberg TVF and start to go crazy. The read Iceberg TVF can be used in joins and aggregations, so you don't have to use kind of a schema and then static tables to get data in. You can just use it in place in your queries. This also allows you to analyze your data in situ, meaning you don't actually have to move it into Firebolt to then do high performance query processing on top. For example, we support the Snowflake Managed Catalog, and I'm excited to actually demo this to all of you later. We support Google Big Lake Metastore. We support Amazon Glue. And we also support pretty much any other Hadoop or REST-based Iceberg catalogs and tables that you create. So for example, if you create a table with PyIceberg, Firebolt is now going to be able to read this directly. Throughout this year, our goal is to make Iceberg as fast as our FFF managed storage. There's already a lot of work that happened here, and we're going to continue to invest heavily into this throughout the year. So already today, as you try out Iceberg, you're able to leverage all of Firebolt's scale-out query engine performance. So you can do massive joins, high cardinality aggregations, and it all ties directly into our query processing stack. We're also working on adding SSD caching to Iceberg right now, which allow for low access latency if you touch the same Parquet files multiple times. This way, you'll actually get the performance benefits of hot storage that you enjoy with FFF on Iceberg 2. We've already integrated Iceberg with our sub-result caching infrastructure, which means that we can leverage computation across queries. So if you run a homogeneous workload on top of Iceberg, there's a good chance that sub-result reuse will help accelerate that workload. Finally, we're hard at work to actually make pruning on Iceberg as effective as possible. For this, we're leveraging both Iceberg metadata as well as Parquet metadata. We'll continue to kind of launch performance improvements throughout this year. And of course, we'll publish engineering blogs, kind of post on LinkedIn and so on, as these performance improvements make it into our product. Beyond adding new SQL features and making it easier to work with your data in Firebolt, we're continuously investing into security. Beyond ISO certifications and SOC 2, I'm really happy to announce that Firebolt is now also HIPAA compliant. This means that it's easier now to run more healthcare workloads on top of Firebolt, and we're excited to bring that to our customers. Additionally, we've just launched AWS Private Link Access. This means that now, if you leverage that, your queries and result sets never go through the public internet. You can use the private link access directly to connect to Firebolt, and nothing is ever routed kind of through the public net. Finally, we've continued innovating and adding support for more objects within role-based access control on Firebolt. Nowadays, we actually give you fine-grained control over all Firebolt objects. This starts at your global organization, goes into your Firebolt account. You can protect the engine, so your compute resource within Firebolt, and you can also protect all data entities as well. So databases, schemas, tables, and views. And you can also protect location through RBAC, which is a new security feature we're launching. With location in Firebolt, you can actually decouple who has access to credentials and who can use the object protected through those credentials. So for example, a security admin within your organization could set up an object storage location, knowing the credentials, and then grant read access to the objects stored in object storage to your users. The users who leverage the location do not have to be able to use or see the credentials themselves. You've already seen for geospatial and Iceberg that we're doing a lot of heavy lifting behind the scenes to make this as fast as possible. Beyond investing into performance of new features, there's also continuous effort happening behind the scenes to make Firebolt as efficient as possible and push the envelope here. This is ultimately what allows us to do so well in the benchmarks that Cole presented earlier. It's really hard, continuous work across our entire database stack to innovate around price performance. So just over the last couple of months, we, for example, improved data pruning on non-primary index columns. This means that even if your kind of column isn't part of the sort or partitioning key of your table, you're now able to do data pruning on top of it within Firebolt. We've improved join planning. We've improved the performance of our numeric functions. We've completely rebuilt our data shuffling layer to be able to make use of high network bandwidth on public clouds nowadays. We've also just presented some of our innovations around query optimization at an academic database research conference. At this point, Firebolt has the best support in the industry to decorrelate aggregate subqueries. We've invested into side-use information passing in joins and improved the coverage of our sub-result reuse infrastructure. We've also launched automatic background storage optimization. This means that if your Firebolt engine has spare CPU cycles that are not leveraged by queries, we're actually continuously optimizing our storage format to make sure your next query can run even faster. As you've seen, we're continuously investing into both price performance, new features, and new security features. Another big thing we're excited to announce here at Firebolt Forward is that we're giving you the freedom of choice to deploy Firebolt wherever needed. This means that all of these improvements kind of will run in the environment where you actually need it. In addition to our fully managed enterprise offering, we're launching a fully managed standard offering, and we're giving you the option to self-manage Firebolt with our free Firebolt Core offering. Let's first take a look at our changes to the managed offering. With Firebolt editions and instance families, we're basically adding 2 dimensions in terms of flexibility to our managed offering. The standard offering we're introducing comes with all of the performance features you know and expect of Firebolt. Our high-performance query engine, scale-out data processing, sparse indexing, aggregating indices, and so on. The enterprise version on top of that comes with advanced security features like HIPAA compliance or the AWS private link connectivity I mentioned before. Additionally, the enterprise version comes with auto-scaling for your workloads. Both of these Firebolt editions now come with different compute families. This means you can choose compute for your engine based on your workloads. If you have a large working set where you need very low access latencies, you're going to want to use the storage optimized family, which has very large ephemeral SSDs attached to the engine. If your working set is smaller, or you're fine with doing cold reads every now and then, you can leverage our new compute optimized families to further reduce the cost of your workload. On the standard edition, an FPU hour now costs 23 cents compared to 35 cents on the enterprise edition. And this means that actually for these compute optimized instances, the cheapest engine on the standard tier is now below $1. If you don't want to use Firebolt as a fully managed service, we are now also launching our Firebolt Core offering. Firebolt Core is free to use and self-hosted, and you can really deploy it wherever you want. You can run it on your own laptop, you can run it on AWS, you can run it on GCP, you can even run it in your data center if that's what you want. And we package it as a single Docker image. So you just pull that from a container registry, and you can start working with Firebolt Core. Beyond that, Firebolt Core out of the box comes with all of our distributed query processing power. This means that you can take multiple instances in your cloud environment, for example, and connect them to one core cluster to start getting high performance on massive joins, high cardinality aggregations, etc. We want to make core incredibly easy to use. This means that there are no dependencies on external services. Core doesn't talk to any Firebolt endpoints, and core also doesn't require provisioning complex third-party services, for example, for metadata management. All of this is baked into our core image itself. There's also minimal user-provided configuration required here. So if you spin up a core cluster, you really just provide the IPs of the other core endpoints. Everything starts working out of the box, and you can do scale-out query processing. I'm now really excited to actually jump to the demo and show you many of the product innovations I've just talked about in action. All right, let's jump in. I'll now give you a demo on many of the things I've mentioned previously in the product innovations talk. Specifically, we're going to see Firebolt Core, so our self-managed free offering running on GCP, integrating with Snowflake Polaris tables, so Iceberg tables managed by Snowflake. First off, I've brought up 4 instances on GCP. These are running in US Central. And I've set up port forwarding to my local machine. Firebolt Core by default is listening on the Fire port, so 3473. Let's run select 42. For now, nothing is happening. On this specific instance, I haven't brought up the Firebolt Core container. At this point, we can connect to that instance. And what you will see is that we have a Docker Compose file lying around. Let's take a look at that. So this is an example of what a multi-node Firebolt Core Docker Compose file looks. You can see that we're referencing this GitHub container registry image. If you try to run this yourself because you're excited about Firebolt Core after the demo, it's not going to work. Core is still in private preview. If you want to try it out, send me an email, connect with me on LinkedIn, and we'd be happy to give you access. You can also see that we're exposing a few ports. These are needed by the Firebolt Core nodes to talk to each other. For example, to shuffle data around or do health checks. We're also mounting this JSON file as configuration. And all that's in here is actually the other nodes. So if we bring up a multi-node Firebolt Core cluster, obviously the individual nodes need to know where to find the other nodes in the cluster. This is all there is to it. If you bring up a 100-node Firebolt Core cluster by yourself, all you have to do is fill in the endpoints or have automation that creates that JSON file, and you can provision that cluster and start running queries. At this point, let's bring up the actual Docker container. We're going to run Docker Compose up, and what you're seeing is that the container is starting. Now, when I go back and run against the Fire port, select 42 suddenly returned. This is because Core is now listening on the Fire port for queries, and I can start sending queries its way and do my data processing. Note that this comes with all of the query engine features of Firebolt. So this means you can do scale-out processing, kind of shuffle-based, distributed query processing, large joins, high cardinality aggregations, all the things you expect from a high-performance scale-out query engine, just on your own hardware, on your own terms. At this point, let me jump into the Firebolt CLI. It's just a nicer way to run these SQL queries and not to always have to use curl. If I run the same thing as before, select 42, you can see the query result comes back and it's formatted in a nicer way. The 260 milliseconds are because the query has to jump over the Atlantic. I'm based in Munich, Germany. The GCP instances are running in US Central at the moment. All right, it's time to run our first Iceberg query. And what we're doing here is actually what I mentioned earlier with this read Iceberg TVF. So you can compose this in a nice way within your SQL dialect. You don't need to set up any Iceberg tables or anything like this. Just call the read Iceberg TVF, and we connect to the Snowflake Polaris catalog. So this is basically the REST catalog endpoint of Snowflake Polaris for our Snowflake organization. And we've created the FireScale data set here. So this is the benchmark that Cole presented earlier, where Firebolt is kind of doing really well on low latency and high concurrency. And we've set up the data set with 100 gigabytes of data, so scale factor 100. We need to pass in secrets and IDs as well. I've prepared these before the demo. All right, time to run the count star. Now, Firebolt is connecting to the Polaris catalog, fetching the Parquet files that make up this iceberg table, and extracting the overall row count. There's a lot of heavy lifting behind the scenes here, and this is really the first time we're able to show Firebolt integrating with the open iceberg ecosystem on Firebolt Core, which is itself a free offering. If I run this a second time, Firebolt notices that it's seen this table before. It still takes a bit to kind of go to the Polaris REST catalog and get back our response, but at this point, result caching kicks in, and we're able to run the second count star in a faster way. In the next step, let's actually query some real data. For this, I'm going to set up views which just reference these create iceberg tables. I'll start with setting up a demo database. And now I'll prepare the create view statements. What you can see here is that we're creating 4 views in total, which simply reference these tables that we've mentioned before. So these are the Firescale 100 gigabyte tables. And as I run the create view commands, you can see it's taking a bit. We want to make sure that when you create a view with read iceberg, everything will actually work once you query it. So the create view command here actually resolves the read iceberg table, makes sure that Polaris table exists, and then sets everything up in the background. At this point, we can start querying the underlying views. So when I, for example, select the ID, agent name, and operating system from the agents table, we'll again, in the background, call that read iceberg TVF, and we get back 10 Mozilla agents running on Windows 10. In the same way, I could also query the rankings table, for example. Again, this is the first time we're actually able to show something like this running on Firebolt. So far, while we integrated with Parquet files and data lakes on S3, we haven't been able to actually query iceberg tables. Us integrating with that ecosystem now allows us to query iceberg managed tables on Snowflake, BigQuery, and really any other way you create an iceberg table that uses the Hadoop or REST catalogs. All right, at this point, let's take a look at what happens when there's changes to the upstream tables. So I might query that agent table and look if there's any agents that have my name in it. As you can see, at the moment, this isn't the case. Why would an agent be called Benjamin? Let's now change over to Snowflake and actually take a look at what happens when we insert that row into the underlying Snowflake table. Now in Snowflake, when I show the tables, you see that we're working on the same data. So these are the Polaris catalog managed tables of our Firescale benchmark. And I'll insert the Benjamin agent here running on Mac OS. All right, perfect. Time to switch back to the Firebolt part. All right, we're back in Firebolt. Now, let's again look at those agents. And what you can see is that the agent suddenly shows up within your Firebolt query. So these are really the changes in your source system propagating instantly into Firebolt. This means that as you make changes to your upstream iceberg tables, Firebolt knows about those instantly, kind of as the catalog changes, and can then give you the most up-to-date data. I'll at this point in the background jump back into Snowflake and delete that row again. So in the same way as before, we've seen that row show up. Now, when I query that agents table again and look for the Benjamin row, what we'll see is that the result is empty again. So here as well, updates, deletes, inserts, all of these things happening in your upstream Snowflake tables will be instantly reflected once you run it back in Firebolt. What this means for you is that for the workloads where Firebolt is the most compute efficient and our query engine gives you the best price performance, you can retain your data within your Snowflake managed Iceberg tables and just leverage Firebolt for the workloads where we give you the best price performance. To close this demo, I want to run a more complex query, which is part of our FireScale benchmark. Within this query, there are quite a few things happening. As you can see, we're running window functions, we're running aggregations, and we're even running joins. So this is on top of that 100 gigabyte FireScale dataset running on Firebolt Core. And this is one of these queries we've actually taken from our production workload, so something a real Firebolt customer is running in production every day, and moved over to our FireScale synthetic dataset. What you can see is that the query results here are returned after about 11 seconds. Given that we're doing joins, aggregations, and window functions on top of 100 gigabytes of data, this is pretty solid. Now, if I run the query a second time, we're seeing the same thing we saw earlier with the count star query. Firebolt sees that data upstream hasn't changed and can leverage sub-result and result caching to return you the query result within 3 instead of 11 seconds before. All of these things combined are really huge changes to the way you can use Firebolt now. Firebolt Core is allowing you to run Firebolt's query engine for free on your own infrastructure, be it on GCP, AWS, on your laptop, or in your own data center. And us integrating with REST and Hadoop catalogs of Iceberg allows you to now actually use the power of our query engine in a far easier way. You simply point Firebolt to your upstream Iceberg catalogs, everything starts working out of the box, and our performance features are kicking in. I also want to highlight that this is actually the first time we saw Firebolt working over GCP object storage. So this is another cool thing that we've been able to see as part of this demo. If you want to try out Firebolt Core, I'd be happy to kind of give you access to our private preview. So just reach out to me and let's chat. Now I'll pass the mic on to Hiren, our head of product management, to talk about our upcoming roadmap.
Thank you, Benjamin, for sharing some of the exciting innovations that are happening here at Firebolt. Hi, I'm Hiren Patel. I lead product management team here at Firebolt. And before we dive into product strategy and vision, it is important to understand how we shape them. Our focus is on developing a product that aligns with customers' need, empowering them to develop data application effortlessly while ensuring low latency, high concurrency at low cost. Traditional data platform solution often struggles to balance between speed, scale, and performance, making it difficult for users to build high performing application. Firebolt is purpose-built to overcome this challenge, delving into sub-second performance at scale while keeping cost in check, making it an ideal choice for modern data applications. With AI wave, and as users become more AI-driven, AI is shaping how the users are going to interact with analytics platform, demanding faster and more cost-effective insights from diverse data sources. To address this, we are investing in 3 key pillars: Lakehouse integration for seamless access of structured and unstructured data, cloud data warehousing capabilities for high performance, scalable analytics, and modern data application to unlock deeper insights and automation using AI. Let's start with one of the investments that we are doing in modern data application pillar. Our focus here are in 2 key areas: enhancing the end user experience using AI, where we are building AI specific Q&A chatbot for Firebolt itself, enabling users to develop their applications from text to SQL, providing AI-driven workload optimization tool such as primary and aggregated index recommendation, and AI-powered migrations from other platforms to Firebolt. Empowering users to build AI applications with Firebolt is another category that we are investing in, where we are investing in enabling AI ecosystem integration by allowing users to call AI services from Firebolt itself, extending our vector search capability with additional similarity functions, adding Python UDF support to extend analytics capability and expressibility from end user standpoint, and even introducing Python language head on top of Firebolt itself so that users can develop application in pure Python. The second pillar focuses on lakehouse integration, enabling users to leverage data in various formats to build applications with Firebolt. There, we are mainly investing in Iceberg, where we are adding capability to read data from Iceberg table, write data into Iceberg table, integrate with catalogs, mainly the REST catalog, and also improving performance when you are reading, writing, or querying Iceberg data as well. At the same time, we also want to invest where Firebolt is and catalog for Iceberg. The third pillar focuses on cloud data warehousing capabilities, where we are investing in advancing Firebolt core architecture, ecosystem integration, and performance and scalability. In core, we are investing in standard edition, a low-cost offering for efficient data warehousing. Also, we are investing in Firebolt core. You can think about it as an installable library for greater flexibility, integrating with Kafka as a streaming ingest scenario, and also investing in core security and compliance feature like fine-grained access control and state ramp compliance. From an ecosystem standpoint, we are investing in integrating with BI tools like Power BI. For developers, we are integrating it with GitHub so that enabling collaborative development environment. Also want to add capability where users can read and write data from Azure or GCP storage layer. And also bridging a gap between Postgres and Firebolt by adding more Postgres specific capability. From low latency and performance optimization perspective, we are investing in purpose-built SKUs like storage optimized or compute optimized SKUs for specific workload. We are improving data pruning enhancement, so for faster query execution with intelligent filtering, improve code execution speed up by investing in JIT compilation, and also improving our runtime operators itself. From a scalability and observability standpoint, we are investing in auto scaling, where dynamically scale for efficiency and load handling. We both scale up and scale down engines as the load goes up or down. Also investing in sub-second engine starts. Today we take a few seconds, but how can we go further and make it actually sub-second engine start itself? And also on a cold start, how we can make sure that query performs more efficiently. So warm-up policies around that and observability enhancement. With that, to walk you through a real-world use case on how you can build AI application on top of Firebolt, I would like to introduce David Stenko, our amazing intern, who will demonstrate how Firebolt enables AI chatbot implementation using high-performing vector database.
Hello, everybody. My name is David Stanko, and I'm working on a Firebolt support chatbot. Our chatbot uses Retrieval Augmented Generation, or RAG, with Firebolt as the vector database. I'm going to demo the chatbot and show how Firebolt enables fast, accurate AI. We built this Firebolt support bot so that users could get instant answers to their questions, eliminating the need to search through documentation or wait for support responses. Using RAG with Firebolt as the vector database, the chatbot efficiently retrieves relevant information, streamlining the user experience. Users can get accurate, data-driven answers without manual searches or delays. Also, we designed the chatbot to serve multiple audiences. Both customers and Firebolt employees can use it for support and troubleshooting. When a Firebolt employee uses the chatbot can use internal Firebolt documents, allowing for more relevant answers. The chatbot won't use those documents at all if the user is a customer. This data privacy protection makes the chatbot usable by both audiences. Additionally, the chatbot could generate documents for Firebolt employees or perform text-to-SQL conversion with a simple prompt change. Now, let's dive into the demo of the support bot. This is the chatbot UI. I'll click here to interact with the chatbot. First, I'm going to ask how are primary indexes implemented in Firebolt. Now I'll give you a moment to read the answer. The chatbot's answer is specific to Firebolt and not about other data warehouses. For example, the chatbot says primary indexes are sparse indexes that sort data into the Firebolt file format. It correctly describes how they are used to prune data. It also gives the right syntax for creating a primary index. Now, let's ask, tell me about Firebolt's aggregating indexes. Again, I'll give you a moment to read the answer. The chatbot correctly states what aggregating indexes are, their characteristics, and how to create them. Again, the answer is very specific to Firebolt. For example, the chatbot says aggregating indexes work together with the F3 storage format. It also says an advantage of Firebolt is that we maintain aggregating indexes even when there are non-update friendly aggregates. Finally, let's ask, what are the advantages of Firebolt? I'll give you a moment to read the answer. The chatbot's answer is exactly right. It mentions all our key advantages, including sub-second query performance, high concurrency, and AI readiness. Now that we've seen the support bot, let's talk about how it works. First, let me explain RAG, which is a technique for improving the accuracy of LLMs. These two diagrams show how RAG works. First, we need a data source. Our data source contains various Firebolt documents. Then we split the documents into smaller pieces of text called chunks. Next, the chunks are sent to an embedding model. Embedding models convert text into vectors called embeddings, which capture the semantic meaning of the text. Next, the embeddings are stored in a vector database. Vector databases are specifically designed for efficient storage and retrieval of vectors. In the second diagram, when the user asks the chatbot a question, the embedding model converts the question into an embedding. Then we perform vector similarity search. From the vector database, we retrieve the top K embeddings that are the most similar to the user's question. That similarity is calculated using a vector similarity metric. Finally, we get the chunks that correspond to those embeddings. We pass those chunks to the LLM along with the question and the prompt. The LLM uses the chunks as context for answering the question. Now that we covered the basics of RAG, let's talk about how we implemented our own RAG system for the Firebolt support bot. Our data source consists of various Firebolt documents, including Firebolt 2.0 documentation, some internal design documents, and documentation for Firebolt development tools. We carefully protected all sensitive data. We have a mechanism to ensure that the internal documents will only be used if the chatbot user is a Firebolt employee. There are many strategies for chunking documents for RAG. Our RAG system supports several chunking strategies, but we saw that semantic chunking was the best for our data. Semantic chunking uses embedding models to ensure that the semantic meaning of the text is preserved after chunking. We used nomic embed text for the embedding model. We used Firebolt as the vector database. Vector database usually only refers to specialized systems that only support vectors. However, Firebolt can store and retrieve embeddings efficiently and at scale. And we support several vector similarity metrics, which we used to perform vector similarity search. In that way, it serves as an excellent vector database for our RAG system. Firebolt is unique because you can use it as a vector database, but also as a general SQL database. On the slide are the columns of the Firebolt table that stores the embeddings. Here's how this table schema streamlines management. For each chunk, the document ID and document name are stored. That way, we know which document that chunk is from. We also have the document version and the date that each row was added. That makes it easy to manage updates to documents. If we update the document later and ingest the updated one, the date generated and the version will be different. So we'll know that this is the most recent version. So if the data source is updated and the old documents become outdated, we don't have to delete the old documents from the table. It will be easy to implement a way to retrieve the latest version of a document. Next, the internal only column indicates whether the document is internal or user-facing. Using that column, if the chatbot user is a customer, we filter out the internal documents, and if the user is a Firebolt employee, we keep them. Also, we can filter by the chunking strategy column to compare different chunking strategies, allowing for easy improvements to the chatbot. We use the cosine similarity as the vector similarity metric. Cosine similarity is commonly used for finding the semantic similarity between two pieces of text. So for our use case, cosine similarity would return the most relevant chunks to the question. Finally, we used Llama 3.1 as the LLM. In summary, we leveraged Firebolt's lightning-fast vector capabilities to build a Firebolt support chatbot using RAG. The support bot will allow customers and Firebolt employees to get immediate, accurate answers instead of manually searching through documentation or waiting for support responses. And we can easily use it for text-to-SQL conversion or document generation as well. Customers can use this same RAG architecture for a variety of use cases. Imagine a healthcare chatbot that instantly answers medical questions by retrieving context from the most relevant medical documents. Our filtering mechanism in the Firebolt table would allow healthcare organizations to mark private patient data as internal and use it only when appropriate. Or imagine a chatbot for legal professionals that retrieves the latest, most accurate legal documents to streamline legal decision-making and research. What about a support chatbot for e-commerce, which can read from a user's order history to answer questions about order tracking? To close out this demo presentation, the takeaway is that Firebolt is a great addition to your data infrastructure to power AI applications. So why use Firebolt for AI applications? The first reason is Firebolt's vector capabilities. Many AI applications rely on vector databases and vector similarity search. Firebolt can serve as a vector database, and it can perform vector similarity search in sub-second time thanks to our low latency query engine. This speed and efficiency is critical for real-time AI applications. Next is scalability. Using Firebolt, AI-powered applications can handle terabytes of data effortlessly. Finally, unlike other data warehouses and unlike vector databases, Firebolt allows you to store vector data and other data in one platform. Specialized vector databases like Pinecone only support vectors, and you would need another service to store other kinds of data. But with Firebolt, you can use fewer services to power your AI applications. The future of AI isn't just about intelligence. It's about speed, accuracy, and trust. Firebolt ensures your AI applications deliver all three. Thank you.
Hello again, everyone. I hope you enjoyed all the sessions that we prepared for you today. We had good discussions about what's happening in the market and how organizations are thinking about AI and adopting it. We had few demos to showcase some of the latest innovation at Firebolt, as well as we heard directly from few customers, Firebolt customers, and benefits they realized by using Firebolt. Before we conclude today's event, I wanted to leave you with few takeaways. Firebolt is the most efficient data infrastructure to support AI-enabled applications by delivering low latency and high concurrency. Millisecond query performance is even more critical in the AI era. Firebolt's multidimensional elasticity delivers the right price performance and needed elasticity to support dynamic AI application needs. Firebolt's high concurrency empowers AI application to handle hundreds of users running their query simultaneously and at the same time. Leverage both structured as well as semi-structured data to contextualize your AI applications and minimize hallucinations. Firebolt provides flexible deployment options, self-managed or fully managed deployment options, and enables you with freedom of deployment choices. And finally, through our integration with Apache Iceberg, Firebolt powers AI applications with your data stored in existing lakehouses. Whether you're building generative AI or agentic AI scenarios, Firebolt is your data infrastructure for creating fast, accurate, and scalable AI applications. I would also like to encourage you to give us a try. We provide $200 credit to try us risk-free and experience everything we discussed and demonstrated today. With this, I would like to thank you all for attending our first ever Firebolt Forward event. I hope to see you again next quarter. Cheers all.
Now, we want to hear from you. We've covered a lot today. Firebolt's evolution, industry insights, our latest innovation, benchmarks, but what question do you still have in your mind? This is your opportunity to get answers directly from Firebolt's leadership and experts. Drop your questions in the chat, and we'll take as many as we can in the time that we have left. All right, let's get started with the first question. And the first question is, what is history-based query optimization on your slide? Benjamin, I think that one was in your slide, right? Like, let me pull you in so you can answer that question.
Sure. So history-based query optimization is one of the things our query planner does behind the scenes to make your queries faster, especially for homogeneous workloads. Basically, what's happening behind the scenes is that the Firebolt optimizer is continuously looking at telemetry of past queries. And by looking at telemetry of past queries, we can then use that telemetry to make better query optimization decisions for your new queries. So if you have a homogeneous workload which has similar query patterns running over and over, basically our planner gets smarter over time and your query plans become better and better to give you the best price performance.
All right, let's see this next question. How does Firebolt balance low latency queries with high concurrency workloads, especially for AI applications requiring real time? Igor, I think this one's for you. Would you mind coming in and answering the question?
Yeah, absolutely. That's a very, very good question. At high level, we think, as we discussed, we think about low latency as the core value proposition. So efficiency is something that is built into the product throughout the query execution stack. And so we really look hard into every single aspect of the query execution as it goes through various aspects of our execution stack and try to optimize and provide that low latency experience. That starts from, as we start thinking about compiling the query, creating that optimal plan and how that query will be executed once the execution starts, all the way to looking very, very hard into every single query operator and trying to figure out what's the most effective and most efficient way of executing that particular operation within our infrastructure, within our engine. And so that ensures that we deliver for a single query, we deliver the most efficient and optimized execution strategy. Once that single query is optimized from the execution perspective, that assumes also how much CPU as well as memory allocation we allocate for that particular query. The very next step is how do we ensure that under high concurrency workload, we can actually achieve those low latency scenarios. And the answer is around our admission control and the scheduler. So what happens is, as under high concurrency load, lots of queries obviously come to our engine for processing. And depending on what's happening at runtime within the engine, we will start admitting or pausing or planning those queries when we actually admit those queries into our system. And so depending on both CPU utilization as well as memory utilization, we'll start sending requests until we saturate the resources that are available for executing those queries within a single engine cluster, if you will. And then depending on the cluster configuration or other engine configurations, we also have ability to actually provision additional clusters that are completely transparent from the user's application. And if user enables auto scaling for concurrency, we can, once a first cluster is exhausted from the resource perspective, we can start both bringing the second cluster up and running as well as scheduling additional queries on that newly provisioned cluster until we exhaust additional resources there as well. And so high level is, first we optimize the query execution for a single query, and then we start scheduling as the queries are being sent to a particular engine cluster, we start scheduling and bin packing those queries on that particular cluster until we exhaust the resources. Once the resources are exhausted, we can actually schedule other queries on additional clusters, which leads both to high concurrency as well as second thing is low latency performance, which is not compromised under the concurrency scenarios.
Well, thank you, Igor. That was very helpful. All right, so we only have time for the last question. So I'm going to pull 2 questions in. One of the questions is, can I upload my own polygons? And the second question is, can we upload public geo data into Firebolt, like OpenStreet datasets with roads, city boundaries, etc.? Benjamin, this one was also in your section for geospatial, so I'm going to pull you back in.
Sure, happy to answer. So yes, all of that works. For the first questions, you can store polygons with holes, you can store arbitrary combinations of that. So we support all of that within our geography type. And in terms of OpenStreetMap data, sure, that works as well. As long as it's in GeoJSON, well-known text, well-known binary, or the extended formats, you can just ingest it into Firebolt and start running queries on top of that.
If you find today valuable, let's keep the discussion going. Share your thoughts with us on LinkedIn or X using the hashtag FireboltForward. Thank you all for being part of Firebolt Forward. We appreciate your time, your curiosity, and your questions. We'll see you next time.